Congruence and similarity. Congruent shapes have the same size and shape. We can see that all of the corresponding sides of this pentagon to the left are exactly the same as the pentagon over here to the right. Same with these two rhombi, or plural for rhombus. Two figures are congruent if the second figure can be obtained from the first by a series of translations, reflections, and/or rotations. And the reasoning behind that is that all three of these preserve image size and shape. Similar shapes have the same shape, congruent angles, and proportional sides. For example, 4 to 8 reduces to 1/2, 3 to 6 reduces to 1/2, 5 to 10 reduces to 1/2. That common ratio is shared among the sides, making them proportional. And two figures are similar if the second figure can be obtained from the first by a series of translations, reflections, rotations, and/or dilations. The key with similar shapes is there has to be a dilation involved. It can be just a dilation, or it could be a mixture of, say, a dilation and a translation, which kind of looks like what this one is. It could also be a dilation and a reflection, like this one, or it could be a dilation and a rotation, or any combination. As long as the dilation takes place, the shapes are similar. What would the value of J have to be in order for the figures below to be considered similar? Well, since similar shapes have congruent angles, we could determine the measure of this angle. Since we have two angles in a triangle, we know that all the angles in a triangle have to add up to 180, and we could find that value. And then J is in that same corresponding position, so J would also have to be this angle measurement. So we can do that by taking 180 and subtracting both 33 and 112 from it. And when we do that, we end up getting 35. So this angle here is 35 degrees, and then in order for these to be similar, J would also have to be 35 degrees. Are the two figures below considered to be similar? Explain your reasoning. Well, in order for figures to be similar, they have to have congruent angles. So let's see if this third angle in this triangle ends up being the same in the other triangle. So first we have 150 and 20 degrees. If we add those up, we get 170. And then if we take 170 and subtract it from 180, we end up getting 10 degrees. So 10 degrees is the measurement of this angle. And we can use the same strategy by adding up 10 degrees and 20 degrees. And when we do that, we get 30. And 180 minus 30 will give us 150 degrees. So that'll be this obtuse angle in that triangle. Okay, so we can see that all of the angles are indeed congruent. Now let's look at the side length ratios to see if they are in proportion to one another. So we have 3 in between 20 and 150. Okay, 20 and 150 over here goes with the 5. So we have a ratio of 3 over 5. Now if we look at the side between 150 and 10 degrees, that's 6, and it corresponds with 10 on the other side. So does that equal 6 over 10? Well, if you reduce 6/10, it does equal 3/5. And let's also compare the last set here. We have 8. Is it going to equal 8 over 13 1/3 would be 39 plus 1, 40 thirds. And what we can do to get rid of the fraction in the denominator is we can multiply both of these by 3 over 40 So they cancel out in the denominator. So we have 8 times 3 is 24 over 40. And does that reduce to 3/5? It does. So all of the side length ratios are the same and reduce to 3/5. And all of the corresponding angles are congruent. So we do have similar figures. So our answer here is yes. Corresponding angles are congruent and sides proportional. And here we have the solution to our problem explained. Yes, the two triangles have congruent angles and proportional sides. Therefore, they are similar to one another.